We are beginning Unit 4. Y'all have had, like I said, you had the pre-assessment last week that was due last night. And then you had some skills check practice yesterday while I was out at a tournament. So today is our first set of notes for the unit. And we're going to start by just going over some of those skills that you should have been practicing in that skills check and in that pre-assessment. So if you didn't finish any of those or you got stuck on any of those, this should clarify anything. We're refreshing our skills on like prerequisite stuff we need to be able to do. Okay. So first of all, the symbol for absolute value is the vertical bars to the left and the right of whatever the value or expression is. So right here, when you have that bar on the left and right of whatever's in here, that means absolute value, okay? And I've showed y'all where that is on Desmos, how to put that in the calculator, but I'll show you again here in a little bit. Absolute value, the definition is that it is the distance from 0 on the number line, okay? It is a distance. Okay, that means that it is always going to be a positive number. Always. Okay, distance is always positive. My L and W are kind of connected there. Sorry, let me make that a little neater. Okay. Think about the odometer in your car when you're driving. Okay, that's what counts your mileage, keeps track of how many miles you've driven. So it does not matter if you're driving in drive or in reverse. You're going forward, you're going backward. The odometer is still going to keep ticking for the number of miles you're driving. Okay, it doesn't matter if you're going in the positive or negative direction. You're still driving. It's still a distance. Give me one sec to grab the phone. Always rings when I'm doing my recording. Sarah? I don't. It's not here. Thanks. Bye. Okay. All right. Sorry about that. So it doesn't matter also forward, backward. It doesn't matter left, right, north, south, east, west. Wherever you are driving, you're going a distance and it's ticking up on your odometer. Okay, so if that helps you think of absolute value that way, that it's always positive. It doesn't matter what direction you're going. So it doesn't matter if I'm going left on the number line or right on the number line. I'm still going a certain distance away from 0, from my starting point. Okay, so that means that every value, every number has 2 possible locations on the number line. Okay, so if I want to be a certain distance away, I can have that distance in the positive direction or that distance in the negative direction. Oh, hello. I don't know what happened there. Something is going on with my stylus. There we go. Okay. So for instance, if I want to be a distance of 4 away from 0 on my number line, where is one location I could be on this number line? I could be at -4 because that is a distance of 4 from 0. Where else could I be? I could also be at +4. Very good, because that is also a distance of 4 from 0. So it is a distance from 0. So here I could be at -4 and I could be at +4. Those would both be values that are 4 units away from 0. Does this make sense? We have to make sure we understand that there's 2 directions you could go in, but both are giving you that same absolute value, right? All right, what's the absolute value of 0? How do you know that? Exactly. Now that kind of sounds confusing. I'm 0 units away from 0, but that's true. If I am at 0, I am 0 units away from 0. Okay, so that's how I know that the absolute value of 0 is 0. So for the how do you know, you can put that in your own words, but I guess I'll say 0 is 0 units away from 0. Okay, or you could say it's a distance of 0 from 0. However you want to word that. It's the best way for you to understand what that means. Okay, so 0 is the only value when we take the absolute that we could only have one possible input to get an output of 0 for our absolute value. Okay, all the other ones, there's 2 because you could go negative or positive, but 0 doesn't have a sign. It's not positive or negative. So that's why there's only one answer there, or one possible input to get 0 as the absolute value. All right, so the rest of this front side is really a like a skills check, a review. We're checking our memory to make sure we know the process for different types of things. So this first one says evaluating expressions. So we're going to evaluate. When we hear evaluate, first of all, it says expression. That is not an equal sign. Notice in this expression, there's no equal sign. So it's not an equation, it's an expression. And we are going to evaluate by inputting these different values that they're giving us. So when you're asked here to evaluate, I am going to plug in the number and solve. So I'm going to plug in and solve, okay, or simplify, however you want to think of that. Okay, so I've got 3 different values they're asking me to plug in and check. So let's start with the x is 0. So we are plugging in, and when it says plug in, it's right here. We're going to plug in for x right there and evaluate. I'll try and keep this color coded. So green is when x is 0. So I'm going to have -3 absolute value of 0 minus 2 plus 5. I am going to write lots of steps. I'm going to write every single little step here for the sake of our notes. I know that when you're doing this later for practice or if you have this on an assignment, you don't have to write every single little thing. Sometimes you'll be able to do a couple steps at once in your head or something. But just for the sake of our notes, I'm going to walk you through step by step and make sure we've all got the hang of this, so we all understand. When we are doing order of operations to evaluate an expression, your absolute value bars fall into the order of operations with like parentheses or brackets. Okay, PEMDAS, remember? So it's going to be that first thing. The first thing we do is parentheses. So this isn't parentheses, but we treat it falls in the same place. So it's the first thing that we have to do before we multiply or divide or add or subtract. Okay, so inside the absolute value bars is 0 minus 2. What does that give me? -2. So I'm going to rewrite this as just a -2 in there. Okay, now what is the absolute value of -2? +2. Good. So I'm going to replace absolute value of -2 with just 2 in parentheses. Okay, I've gotten rid of the absolute value now. I've done that. Now what's next? Yeah, first I'm going to multiply that -3 times the 2 there. Okay, so -3 times 2 is -6. Then I'm going to add the 5. So I end up with -1. So I simplified inside the absolute value bars. I took the absolute value and then I multiplied and then I added. Okay, that was the order of operations that I followed. Okay, so I'm going to do the same thing again. This time you're going to do for x is -2. All right, so we've got -3, absolute value of -2 minus 2, and then plus 5. So what do I do first? Yeah, -2 minus 2. What is that? -4. So I've got the absolute value of -4. And then that's -3 out front still and plus 5 at the end. Now what? Good. So a common mistake, I'm just going to point this out here, is to multiply those, -3 and -4. I don't do that yet. I still have absolute value bars there. I've got to get the absolute value before I do the multiplication. So the absolute value of -4 is +4. Good. So I'm going to replace then that with a +4. Now I can multiply and get -12 plus 5, -7. Still with me? Okay. All right, let's do this last one. Say where x is 2. So we're going to have -3 times the absolute value of 2 minus 2, and then plus 5. What's 2 minus 2? 0. So we've got the absolute value of 0, which we just talked about is what? 0. So I'm going to replace absolute value of 0 with just a 0. And then 0 times anything is what? 0. And then I add 5, so I get 5. So again, I wrote that out, 1, 2, 3. I did 5 lines for each of these. I do not expect you to do that every single time. I would probably expect to see the work that I would like you to show would be this first step where you write what with the value plugged in, right? Okay, what it is we're doing. Okay, and then I would imagine most of you can do this addition or subtraction inside in your head and then take the absolute value and get to here, probably without writing that other one down. And then I would imagine most of you could say, okay, that's 0, add 5, that's 5. So like I would expect maybe just those 3 lines. Does that make sense? Fair enough. Show me at least that much work. You can skip the ones in between if you want to do those in your head. Good? Did we use distributive property on any of those? We did? We multiplied. Yeah, we multiplied. But distributive property is when, like, distribute means like hand out, right? Pass out. So distributive property is when you're when you've got multiple things that you're distributing it to or passing it out to. For instance, over here in this next example, this is an understood -1, right? That -1 is outside the parentheses, and so I'm going to distribute it to both terms inside. But over here, I didn't distribute, for instance, that -3 into the 0 and the -2, right? I multiplied right here, but I didn't have to. That's not distribution because I didn't have to have the parentheses there. The absolute value of -2, I could have just written that as 2 times. I could have written it like with a dot or a multiplication symbol instead of parentheses. Okay, so that's not distribution. That's just multiplication. But thank you for pointing that out so I can clarify. Just because there's parentheses doesn't mean it's distribution. Okay? But so we did not use distribution on those, but we are going to use distribution over here on this next one. Okay? Notice the difference in these two equations, and they're equations this time. They have equal signs. We have 7 equals 4x minus 9. And then we have 7 equals -4x minus 9. And that negative is outside the parentheses, so it has to be distributed. So this is a process that you're going to need to get used to, is solving two very similar equations. What was the only thing different about these two equations? Yeah, having that negative that needs to be distributed, right? Okay, because when we start to solve absolute value equations, we set up here that any number is going to have two possible locations, a positive and a negative. So when we go to solve absolute values, that's what we're going to do. We're going to have something set equal to a positive and something set equal to a negative. Okay, and we're going to have to solve both because there's going to be two possible solutions. Does that make sense? Okay, so that's why we're practicing this. Okay, so this is without absolute value, just basic algebra. I'll start with this one on the left here. So if I want to solve the equation for x, I'm trying to isolate my variable x. What do I move first? And how do I move that -9? So opposite operation, I'm going to add or subtract if I have a constant. A constant's a number without a variable. So if you have a constant added or subtracted in your expression, we'll get rid of that first. And when we say get rid of, we're talking about the left and right side of the equation. We use opposite operation, and what we do to one side, we do to the other. So 7 plus 9. And I'm left with just the 4x here because the -9 plus 9 eliminated. Okay, and then what do I do to get rid of the 4? Yeah, because that's right now it's 4 times x. So the opposite operation is to divide. And what I do to one side, I do to the other. That reduces to just a 1x. And 16 divided by 4 is 4. Okay, so I'm going to do the same process over here, except first I have to do the distribution. So this is going to become -4x. And then that'll be plus 9 because a negative times a negative becomes a positive. So now what am I going to do? So now this time I'm subtracting 9 with the opposite operation. And what I do to one side, I'm doing to the other. So I end up with -2 equals -4x. And then when I go to divide, I have to divide by -4. What's a negative divided by a negative? Positive. That 2/4 just reduces to 1/2, so positive 1/2. So that's saying that if I plug in a 1/2 there, it would make this equation true. And this is saying if I plug in a 4 here, it would make this equation true, right? Okay. All right, the next skill we're going to refresh our memory on is slope and graphing with slope. What is slope? What's another way you can refer to slope, or tell me what slope is? I heard rate of change. Yes, what else? Rise over run. Good. I'm going to write that down. Rise over run. Okay, or you could write rate of change. Okay, it's the change in y over the change in x. So on number 3, they ask us to plot the point -6, 0. So first of all, is -6, 0 an x or y intercept? Yeah, I'm going left 6 and up 0 from my origin. So that's my x-intercept. Okay, so that's the point I'm starting with. Now, they say, okay, I'm starting here. They want us to count our slope of 2/3. It says use a slope of 2/3 and plot 5 additional points to draw this line. How can I do that? Okay, I heard up 2 over 3. What's over mean? To the right. Okay, so I'm gonna write this down. I'm going up. Very good. So this is a positive 2/3. So it's a positive 2/3. Up is a positive y movement, and right is a positive x movement. And a positive times a positive, still positive, right? So yeah, we can do that. So rise 2, run 3 means up 2, right 3. And then I could do it again, right? And again. And again. Now I could keep doing that. So I used this process up to right 3 to get each of these additional points. But what's something else I could have done instead? I could do it again to get my 5th point, but I want to make sure we understand that we can go in the opposite direction. How would I do that? Down to left 3. And that would still be a positive slope, because if I go down, that's a negative movement. And if I go left, that's a negative movement. And what's a negative times a negative? So that's still a positive slope between those points. You can see those are all still on the same line. So 2 negative movements means the slope is still positive, right? All right, what about if I start at 0, 7? First of all, what is 0, 7? What type of point would that be? A y-intercept, because it's on the y-axis. Okay, so I'm starting here. And they tell me this time to plot 5 points given a slope of -1/2. So what's one option I have? Down 1 and to the right 2. Okay, so let's try that. I go down 1, right 2. Down 1, right 2. I could do that several times. And yeah, that is down is a negative movement and right is a positive. So a negative and a positive is a negative. If I do negative divided by positive, I get negative, which that's what I wanted. It wanted a negative slope, correct? Okay, so I got all of these by doing that. What's my other option? What could I do instead? I could go up 1, but that would be a positive movement. So to get my negative, I would have to go left. So up 1, left 2. And you can test that by going backward between any of these points. Up 1, left 2, up 1, left 2, up 1, left 2. And that's how I got this point. You'll feel okay about that? And you can see those are all still on the same line. Okay, and that line has a negative slope. It's decreasing from left to right. The first line was a positive slope. It's increasing from left to right. We read our graphs left to right, just like we read a book. Feel good about slope, plotting points? Need to be able to do that. All right, so let's kind of put some of this together, work our way back into absolute values. If I'm going to plot a point or a set of points, and then I'm going to reflect them across the vertical line. Okay, so I'll do this, I'll do A in green. Okay, so there's a vertical line at x equals 5. It's already graphed here. I'm just going to highlight it. And they want us to plot 5, 0. That's on that dashed line. 7, 3. And 9, 6. So I plotted those 3 points. Okay. Now, can somebody first off tell me what the slope is between those 3 points? Yeah, I'm going 1, 2, 3, 2. Positive, positive, right? Up, right? So a positive 3/2. Notice I'm using m for slope, right? Mx plus b, m is slope. Okay, when I use m, you know that that's slope. All right, now it wants us to reflect those points across that line I highlighted. So if I'm going to reflect across that line, first of all, if I'm on the line, can I reflect across it? No, so that point's not going to go anywhere. It's going to stay as is. But this point at 7, 2, where would I end up if I reflect across this vertical line? 7, -3 would put me down here. I don't want to reflect over the x-axis. I want to reflect over this line at x equals 5. How far away from that line am I if I'm right here? Yeah, I'm 2 units away. I'm 2 units to the right. So to reflect, I need to be 2 units to the left. So I need to be right here. Okay, so that is at 3, 3. So the reflection, come on, of that point put me at 3, 3. This point didn't change, stayed 5, 0. Okay, what about the other one? When I reflect, yeah, because I'm 1, 2, 3, I'm 4 units away from that line I want to reflect over. So I go 1, 2, 3, 4 units in the opposite direction to get that reflected point. And that's at 1, 6. So notice I am equidistant away from that dashed line, the left and the right. Do y'all agree those are equidistant away, left and right of it? Equidistant means equal distance. So it's like what we were talking about on the number line when we were measuring a distance from 0. We said we could go to 4 or -4, and they're both 4 units away, just in opposite directions. It's the same thing here. Now, instead of starting at 0, we're starting at this line at 5, but I'm 4 units away, 4 units away to the left, 4 units away to the right, but it's the same distance, correct? Okay, now when I connect these, it makes this V shape, doesn't it? That should look familiar. We talked about in unit 2, the parent function of absolute value. We said it made that V shape. Well, this is why, because if I go an equidistance away to the left and right, okay, if those points are reflected over, that's what creates that V shape. Okay. So notice there's 2 possible points that give me that distance from that dashed line. What is that dashed line called? If it's something that I can reflect over, my graph, the axis of symmetry, very good. So that's my axis of symmetry for this graph. Okay, and everything reflects over. If I folded it on that line, everything matches up. Okay, well, what's that slope here of the left side that I just created with the reflections? What's that slope if I count between those points? Okay, +3/2? Yeah, this one's negative. If I go from left to right, I'm going down 3, right 2, down 3, right 2. So this is -3/2. So it's the opposite slope. Negative on one side, positive on the other, but the points reflect each other. Okay, let's do the same thing. Let me get a different color here. Do pink here. Let's look at this line at x equals -4. That's my axis of symmetry. Okay, and I'm going to plot these points at -4, 4, -2, 3, and 0, 2. Okay, first of all, before I do anything, can somebody tell me what the slope between those 3 points is? Now, if I'm going left to right, I'm going down 1, right 2. So what is that? That's negative, because I'm going down is a negative, right is a positive. A negative divided by a positive is a negative. So -1/2. Okay, now I'm going to reflect those points. So the one that's on the axis of symmetry obviously does not reflect over. Okay, but how far away is this next point from that axis of symmetry? It's 2 units to the right, so I want to go 2 units to the left of that to get the reflection. Okay, and that next one is 4 units, so I want to go 4 to the left to get that reflection. So here are the reflected points over here. Okay, so that's at negative 6, 3. And at negative 8, 2. And the one that was on there, it didn't move. It stayed negative 4, 4. Okay, what's the slope between those lines? Yeah, if I look here, if I go to connect these, that's positive left to right. It's going up 1, right 2. Okay, this side was negative. Okay, so that's also an absolute value function. That one's just flipped upside down, y'all, right? It's that V shape still, just upside down. So let's talk more about that parent function. Review what we talked about in Unit 2. We did all the parent functions and their key features. Absolute value was one of them. Absolute value was one of the ones we focused on that Unit 2 retest as well. Okay, we went back over those key features and what the parent function looked like. Okay, so the parent function, if you need a table, make a table. Okay, if I am inputting these x values here, I'm taking the absolute value of them. What's the absolute value of negative 4? Positive 4. The absolute value is always positive, right? So it doesn't matter which number I input, I'm going to get the positive output. So this would be 3, 2, 1. What was the absolute value of 0, did we say? Just 0. Okay, and if I input positives, my output's still going to be positive, isn't it? So this will be 1, 2, 3, 4. So if I plot all of those points, I can see my V shape is centered here at the origin. What is that point at the origin called? On this graph, it's that point where we change from decreasing or from a negative slope to a positive slope. We change directions there. What's that point, that turning point called? So vertex, very good. So I've got a vertex at the origin for my parent function. And that vertex happens to be the X and Y intercepts, doesn't it? Because that's where it's crossing the X and Y axis. Okay, so that's at 0, 0. I'm just going to put in parentheses that that is the vertex. Okay, now what is this line of symmetry for this one, that axis of symmetry? Where is it? Yeah, it's X equals 0. It is the Y axis itself. Y'all agree? So remember, we write axis of symmetry. AOS is the abbreviation. We write it as the equation. So if it's a vertical line, it's X equals, and then where it crosses the X axis, which in this case is at 0. So is there symmetry? The answer is yes. Okay. There is an axis of symmetry at X equals 0. That means that this graph, this absolute value function, is symmetric about the y-axis, meaning it reflects over the y-axis. Now, that's the parent function. If I start to move this graph around, I could move it off center, right? And then it wouldn't reflect over the y-axis anymore. So the second part wouldn't necessarily hold true, the symmetric about the y-axis, but it would still have an axis of symmetry. It would just change from X equals 0 to somewhere else, right? So it's all these absolute value functions are always going to have an axis of symmetry. It just won't always be the y-axis. Everybody understand that? All right, what's my domain here? How far left to right does this graph go? Yeah, domain is your x's, your left to right. And this graph goes left and right forever, and there's no breaks in between. So I'd say negative infinity to positive infinity. Remember, that's my interval notation with parentheses or brackets. When it's infinity, we always use parentheses because we can't ever include infinity because we never get to infinity. We're always just approaching it. Okay, what's another way that we could write that it's everything? All real numbers. Okay, so you could use that all real numbers symbol to indicate that it's negative to positive infinity. Okay, and then range. Let's see, low to high, Y values. Does this graph go down forever? Ooh, this one doesn't. So it did go left and right forever, but it doesn't go up and down forever. It does go up forever, but what's the lowest it gets? 0. So this one's not negative to positive infinity, it's 0 to infinity. And on the 0, what should I use instead of a parenthesis? A bracket, because the 0 is included. The bracket means the value is included. It exists at Y is 0. Okay. Everybody feel okay about that? Now, this other part above that says, in your own words, describe why the graph looks this way. I'm going to leave that to you. I'm going to let you put it in your own words. If you want to explain that all of the outputs are positive, because absolute value is always positive. So don't draw this, but just look. This is the linear parent function right here, right? That's just the line parent function. When we take the absolute value, we only get positives. So it's like this bottom piece is reflected up here because the Y values are negative down here, and we want only positive outputs for absolute value. So it's like this left half of the linear function is reflected up because all of your outputs are positive for absolute value. Does that make sense? So you can explain it like that. You could explain it as it's a reflection. All of the points are equidistant from that axis of symmetry. So left and right from there, they go out equidistant. Okay, so a few different ways to explain why it makes that V shape. Okay, and I'll let you decide what makes the most sense to you, what you want to put there for your notes. Now, this is a really cool link. I know we're looking at it on paper, so you can't click on it. I'm going to click on it for us. You can go type this in later when you're doing your practice assignments. This may help you visualize. I'll also put this link on our Canvas. But this is just set up so that we can see the absolute, it takes us to Desmos, but we've got the absolute value parent function in blue graphed here. Okay, that's what we just graphed is the parent function, right? And then it has with these A, H, and K values typed in and sliders for A, H, and K. Meaning I can move this and change the value of A, H, and K and visually see how it affects my graph. So on the parent function, A is the coefficient, the number multiplied in front. The parent function doesn't have any number there, so what's it understood to be? A 1. So that's why A is initially set to 1, because A is an understood 1 in the parent function. Okay, and in the parent function, there's nothing added inside or outside, right? Added or subtracted to the X or outside the absolute value, is there? So it's like those are 0. So H and K are 0 to start with. So that's why we're starting with A of 1, H of 0, K of 0. But let's look at what happens when I change that. So the A value, that's what's multiplied in front. If I make it half instead of 1, now that's in red. The blue is the parent function. What happened to that graph? How would you describe the difference? When you say bigger, what do you mean? Taller? No. What's some words we could use to describe that? Wider? Yeah, wider would be a good one. Okay, so what happened is my A value is compressing my graph vertically. So imagine putting your hand at the bottom on the vertex and your hand at the top and squishing them together. It squished my graph and made it look wider, right? So when your A value is a fractional value, less than 1, that's what happens. It compresses it. But look, if I make my A value bigger than 1, now it looks thinner or narrower, right? It's because like if I had my hands on top and bottom and I stretched them apart, it makes it look taller and thinner. So your A value is a vertical dilation, a vertical stretch or compression. Okay, we'll pick up there in these notes tomorrow and we'll play around with these toggles a little more. Remember, if you're not PSAT testing tomorrow, you're meeting in the pack. Thanks. You